Right, so just we're going to look at confidence intervals for means here. So a confidence interval for a population mean given by mu is an interval of value between two limits together with a percentage indicating our confidence that the mean lies in that interval. So for a given data set with sample mean x bar, provided n is sufficiently large and x dash n is approximately normal, we look at this, what this means here is getting a sample mean, we can then calculate a confidence interval for this. And the more samples we have, the better the confidence is. Now, we're going to look at this 95% sample here, this formula here. The general confidence interval is these sort of notes here. I'll come back to them in a future video, but I'm going to keep going now because I want to sort of, this definition's a bit dry and we can't really sort of work out what it is. So a sample of 60 yabbies was taken from a dam. The sample mean weight of yabbies was 84.6 grams. Giving the population standard deviation is 16.8, construct a 95% confidence interval for the population mean. So what we do here in this particular example is we state our values. So I'm just going to zoom in a little bit. So we have x bar, which was the mean of the sample, and we got a mean weight of 84.6. Okay, and then we get n equals 60 because we took 60 yabbies, and then from this we can work out our sample deviation. So we've got x bar minus, now 1.96 comes from our 90% confidence interval, so we can figure this out with our z distribution, but we'll leave that for the minute. We'll just keep moving. Our standard deviation is our next value here, so let's just rewrite this all over root n less than equal to our population mean, and then x bar plus 1.96 over standard deviation over n. Now, in this space here, let's put our values in. So I'm going to be a little bit lazy and we'll just copy and we'll paste this below just to help ourselves out. So our x bar here was our 84.6 was our mean. So our sample mean has this 84.6 grams. So we'll put this in both. And then we've got our standard deviation on top here is 16.8 grams. So 16.8, and then we get 16.8, and then we did 60 samples. So we end up with 60 samples here. Okay, so we've got that all there, and then we put this in our calculator and we get a confidence interval of 80.3, less than equal to the mean, less than equal to 88.9, and the text, if we're looking at this, has a statement here that we are 95% confident the population mean weight of yabbies lies between these two values here. Now, what we need to actually consider here is this is one sample. Okay, so we've done a sample, all right? And realistically, this could be x1, okay? And that's one sample is 60 yabbies. Now, if we went, you've obviously got our first sample here, we got 84.6, okay? And we build our confidence interval out from this. So each time we're doing samples of 60 trials. So if we get a different one, let's just say these two values here will be the same. Let's just pretend we got one of 90. Okay, so x dash of 2 equals 90. Okay, these are approximately 8.6 wide. So this deviation here would be the mean equals less than, so it's 8.6, so 4.3, so it'll be 90. Oh, let's erase that. 94.3 down to 65.7. Okay, so I'm just making these up here because it's 8.6 apart. So you notice that straight off this second sample would have a sample mean. Now, if you consider the population here, and we're looking at our normal distribution here, and this is the real value, we've got mean here, this first confidence interval might lie from here to here, okay? And so you'll notice that it has this value in here. So we'll call this one, this is the confidence interval from x bar 1, okay? And so that's our 95% confidence interval. Now, this next bit is fact, and it's one of the reasons I didn't stop this back here. This is where we got our confidence interval for. When we do these samples, our next sample here was 65. That's very wrong. Sorry, that should have been 85.7. So this next one, you'll notice, is fully above. So I've picked a random one, and it's like up here. Okay, and this is x2. Okay, and what this 95% confidence interval means is it means that we would keep getting intervals. So let's just, this one here is x bar 7 or whatever. We just keep going down, and we go all, actually no, I'll use 3 so it's clear it's a sequence. Okay, this continues on down to x bar 100. Now, in this sample, because it's a 95% confidence interval, we've done 100 different confidence intervals. This is a fact, okay? Just, I'm letting you know, it's not in our text or anything like that, but it is assumed fact that this means 95 of these confidence intervals contain this mean, okay? At the moment, you can see my diagram's not very good, and we've already got 1, 2, 3 that don't contain it. Or maybe this x1 is wrong, and this distribution should be slid across like this, and maybe that value is not right, and you know, this means that these ones all contain the mean. So it means that out of 100 only 5 don't contain the real mean. Now, this is really important because this is like the concept of what we're looking at here. And so this was a really simple, confident question on how to do this, but what you need to consider is the fact that this is one sample. We're 95% confident the one we've picked contains the mean, but if we do all these samples, 5 of them will not contain the mean, 95 will contain the mean. All right, so I'm going to leave that there. Now, there's one more point, and I'm making this pretty clear here. When we come here, we have construct a confidence interval. Now, the reason it says a and not the confidence interval is this value here. You've got to remember that these questions, a lot of the time, we're only looking at one sample here. It is a sample from one random little sample. We would take lots of samples from this, and that confidence interval would come from having these sort of overlaid here. So the reason we would say we always construct a confidence interval is we're constructing the confidence interval for that one little sample, but most of the time we would want lots of confidence intervals, or we might do multiple trials in there. All right, that's just that question there. I'm just going to leave that there for you, but that's sort of confidence intervals basically there. Thank you.